A warm greetings to everyone. I'm Saipan Kari from CSCAML B section. Today we are going to discuss a topic about approximation of distribution of log returns with normal inverse Gaussian method. Here I gave the content that we are going to discuss in this topic. Introduction, properties, related distribution, examples, conclusion. Introduction: this distribution appears to have been first derived in 1900 by Lawson Counselors as the time a stove reached a certain price for the first time. In 1915, it was used independently by urban shortgunners and Marlin V. Maudsley as the time of first passage of Brownian motion in the field of reproduction modeling. It is known as the Harriot's function. After Hugo Gardner, who described it in 1940, Urban Wall re-derived this description in 1944 as the limiting form of a sample in a sequential probability ratio test. The name inverse Gaussian was proposed by Marcellus Tweddy in 1945. Tweddy investigated this distribution in 1956 and 1957 and established some of its satisfactory properties. The distribution were extensively received by Foucault and Sicard in 1978. Here I gave the graphs of probability density function and cumulative density function. Here I gave the formulas of the probability distribution properties. The probability density function in inverse Gaussian distribution has a single parameter form given by f of x mu comma mu square is equals to mu by root over 2 pi x cube expression minus of x minus mu by 2x. In this form, the mean and variance of the distribution are equal. E of x is equals to variable of x. Also, the cumulative distribution function of the single parameter inverse Gauss-Jordan distribution is related to the standard normal distribution by PR of x is less than x is equals to mu of z1 plus e power mu rho by z2, where z1 is equals to mu by x of x power 1 by 2 minus x power 1 by 2 and z2 is equals to mu by x power 1 by 2 plus x power 1 by 2, where the rho is the CDF and standard normal distribution. The variables z1 and z2 are related to each other by the intensity z2 and z2 plus 4 mu. In the single parameter form, the MGF simplifies to MT is M of t is equals to expression mu of 1 minus root over 1 minus 2t in an inverse Gaussian distribution in double parameters form f of x comma mu comma delta can be transformed into a single parameter form f of y mu of naught comma mu of naught square by appropriate scaling y is equals to mu square x by lambda, where mu of 0 mu mu naught is equals to mu square mu cube by lambda. The standard form of inverse Gauss-Jordan distribution is f of x 1 comma 1 is equals to 1 by root over 2 pi cube expression of minus x minus 1 square whole square by 2x. Summation. If x has an ig mu naught rho I comma lambda naught rho I square distribution for I is equals to 1 comma 2 comma n and all x and independent, then s is equals to formula. Related distribution. Here I gave the formulas of the distribution. The convolution of an inverse Gauss-Jordan distribution and an exponential is used as a model for response time in physiological visual search. Examples. Here I gave some example questions. True false. An inverse normal distribution is also known as Gauss-Jordan distribution. The number, the sum of probabilities of a frog weight would always be either 0 or 1. An expression given as p of x is less than 53 can be composed as 1 minus p of x minus greater than x greater than 53. To know how many frogs are 80 grams or greater, one must use the concept for inverse normal probability. The graph of frog weight will trace a bell curve. The standard deviation is displayed as the maximum point in the distribution of frog weights. Helena can use the inverse normal probability only if the normal probability is nil. The given equation below is incorrect. Answers. False, because the correct statement is a normal distribution is also known as a Gauss-Jordan distribution. False, because the correct statement is the sum of the probability of the fraud rate would always be 1. True, true, true. False, because the correct statement is the mean is replied as the maximum point of the distribution of frog weights. False, because the correct statement is Helena can use the inverse normal probability only if the normal probability is known. True. Conclusion. In statistics, originally in geostatistics, pinging or pringing, also known as Gaussian process regression, is a method of interpolation based on Gaussian process governed by Fourier convenience under suitable assumptions of the Fourier. Ringing gives the best linear unbiased prediction at unsampled location. interpreting methods based on other criteria such as smoothness may not yield the real duty. The method is widely used in the domain of spatial analysis and computer experiments. The technique is also known as linear complete Borah prediction, often avoid linear and Andre Comergaud. The theoretical basis of the method was developed by the French mathematician Gaussian Morgan in 1960, based on the mass disk of Denis G. Grech. The provisioning plot of distance-weighted average gold grades at the with Waterstad Wave Complex in South Africa. Bring south to estimate the most likely distribution of golden based on samples from a few boreholes. The English word is to cream and the most common known is creaming. Both are often pronounced with a hard G. Following an uncertain pronunciation of the name cream, the word is sometimes capitalized as creamy in the lecture. Through computationally instead, it is basic formulation. Creaming can be scaled to larger problems using various approximation methods. Thank you.